All right, so we're going to do 3.5. So for 3.5, the nice thing is it's really no new information. We take 3.4 and we merge it together with 3.1. So all that stuff that we were entering into the calculator with all those equations, we're going to take that, and now we're going to actually solve those equations for other pieces of information. So it's just the merging of the two, which is nice. So we're going to talk about exponential and logarithmic models. Okay. So the first I want to talk about is the exponential growth model. Okay, that equation looks like y equals c times e to the kt. Okay, so just like we did on the 3.1, 3.2 quiz, I'm going to give you all of these equations. You just have to know how to use them and what the pieces represent. Okay, so you don't have to memorize any equations for this unit still. So C is your starting number. K is a constant. T is time. And Y is your new number, or a lot of times we're talking about population in this situation. So like C would be your starting population and Y would be your new population after so much time has passed. And that's the example we're going to look at. Are there any questions about the equation itself? Okay, so here's our scenario. Make sure you write down the information right. Last hour they weren't, and then they couldn't figure out how I solved some stuff. So suppose the population of a country was 4.22 million in 2000. The projected population in 2010 was 6.49 million. Using t equals 0 for the year 2000, find the expected population in 2020. There's like a lot of information going on here. Okay, so we got to figure out what pieces have we been given, and then how are we going to figure out what the population is in 2020. So based on this equation, we're looking for a few things. We're looking for the starting number, like the initial population. We're looking for a constant, how much time has passed, or what they want us to find, and then our new population. So let's take a look at this. What have they given me? They've given me the starting number, right? In 2000, I had 4.22 million. And they also told me that t equals 0 represents the year 2000. So that's my starting number, right? So I know that C is 4.22. Okay, what else have they given me?
Time.
They've given me some time. So how so? Yeah, in our situation, it is like the midway. So in 2010, my population was 6.49 million. So that's almost like an ordered pair, isn't it? Like where they give me time and then they give me the population. So do you agree that I have T? So T is what? T is 10. T is 10. So, and after those 10 years have passed, don't I know the new number, or the new population? Right, the new population was 6.49 million. So I know Y. The only thing I don't know is K. So K is what I'm trying to find. Okay, so in this situation, before I can figure out what the population is going to be in 2020, I have to first find K. And I can find K based on this information that's given. So this is a two-step problem. Step one, we have to find K. Okay, so I'm going to plug in what I know. I have 6.49 equals 4.22 times e to the k times t, which in our case is 10. Okay, so notice I'm using a model like I did in 3.1, and now I have to use my 3.4 skills in order to actually solve this problem, right? So I'm solving this exponential function. So, how do I do that? What's the first thing I should do? Go ahead, Ethan. Yeah, so divide by 4.22. Now, as tempting as it is to put that into your calculator and round it, don't. Okay, remember on that first quiz when I said no mid-problem rounding? Remember those directions? This is what that is talking about. So I don't want to put in 6.49 divided by 4.22 and get a decimal solution, because that is going to throw off my final answer. So I'm going to leave it like this. Now, once I get here, what do I need to do? So I can't make the bases match. I'm stuck, so I have to convert. So I'm going to convert this. Remember that e changes to log base e. So we're going from exponential form to logarithmic form. So I'm going to get natural log of 6.49 divided by 4.22 equals 10k. What's the last step? Just divide by the 10, right? So I divide by 10, and now k is equal to the natural log of 6.49 divided by 4.22, all divided by 10. Now this is my most accurate representation for my constant k. However, for our purposes and the test, to make it just a little bit easier to grade and easier to calculate, I'm going to have you round to the 4th decimal. So in your calculator right now, please figure out what this is. Yeah, what did you get? Yep. So, did everybody get that? Okay, now we're going to come back to this idea of k not being rounded in a little bit. But for now, we're just going to use our constant k value of 0.043. Now, they wanted us to find the expected population in 2020. So, I cannot do any of this until I have figured out my k value. So this information here in yellow really just helps us to get there. Okay, so this is a two-step process. So the second step now is to find the population in 2020. Okay, so let's just go back and figure out the information that we've been given. So we still know the starting number, right? We still know that the starting population, which is C, is 4.22. Now we know that our k value we're going to use is 0.043. And how much time has passed now? 20 years. So instead of 10, I'm now going to use 20. I'm looking for the new population, or the projected population in the year 2020. So I'm going to have y equals 4.22 e to the 0.043 times 20. And notice now I'm right back to where I started in 3.1, right? All I have to do here, I don't have to solve anything. I've already done the solving. Now it's time to actually just plug this into the calculator and evaluate. So everyone right now, type in your equation and see what you get. Did you get 9.973? Okay, now there are two ways that you can write your answer. This is in millions of people, so we don't want to write 9.973 people, right? Because that's not true, nor is that an accurate way to write about people. So you can write million people after it, okay? Or you can convert it to millions of people by just moving that decimal over 6 places, right? That's the easy way. So 9,973,000, right? 9,973,000 people. And then we still need to include people after that. So either one of those answers is an acceptable answer for me. Okay? Now, what happened here is we used a rounded k value. So now I want to look at what happens when we round internally. Like, I want to show you the difference. So now what I want you to put in is y equals 4.22 e to the natural log of 6.49 divided by 4.22, all divided by 10 times 20. I want you to put that into the calculator. Uh-oh. So now when you put this into the calculator, let's see, I think I have it here. Okay, so this is what it needs to look like. I just took 20 and multiplied it by the 10 to give me 2. It's a little bit easier. But you need to put in parentheses this natural log of 6.49 divided by the 4.22. Multiply it by the 2, but then you have to close parentheses around the entire exponent. Okay, so that's what it should look like entered into the calculator. And then you should get 9.981. Okay, now if you think about 9.981 minus our answer that we got by rounding, which was what, 9.973, you get 0.008. So what just happened there is we cut off 8,000 people by rounding to the 4th decimal. Okay, so in a real life situation, this has significant change to the situation when you use this mid-problem rounding. Do you understand the difference of what just happened here? Here, this is an accurate representation of the constant. We would get a more accurate answer. Okay, yeah?
The first time around when I did it, I did get that answer, and it was different from your guys' answer. If I put that on the test, which is the exact one, would it be wrong?
So what's going to happen on the test is I'm going to ask you for 2 things. I'm going to ask you for the k value, and then I'm going to ask you based on that rounded k value, because I'm going to want you to round it, find the new population. So yeah, in that case it would be because the directions are going to force you into rounding. Okay? So follow what the directions say. Okay? Now, in a real life situation, this is a much better answer. Okay? Any questions about this process or anything else about this first problem here? Do you understand that you have to find k first in order to be able to find this new population in 2020? You have to know that constant.
So which one do you want us to do on the test?
I would like you to do this one on the test because we are actually going to round that k value on the test, okay? And you can do the same thing in your homework. I think they ask you to do the same thing in the directions. Okay? Moving on. Okay. The next thing we're going to talk about is back to those investments. So this is example 2, and we're going to talk about compound interest again. Okay, so compound interest, remember, looks like A equals P times E to the RT, or per. Right, do you remember what all those pieces represent? A is the amount of money that's left after a certain time has passed. P is that initial investment. R is your rate, but it has to be in terms of a decimal. And then T is your time in years that have passed. Okay, so here's our situation. Given an initial investment of $800 compounded continuously at 9.5%, find 2 things. A, the amount of time it takes to double the investment, and B, the amount of money after 10 years. Okay, so we really have two things to find here. Okay, that first situation, we're talking about having this initial investment. We know the rate. We don't know the time, but we know we want our money to double. So if I invested $800, then what am I going to get at the end once I double it? $1,600, right? So I know A, I know P, and I know R. I'm looking for T. So I'm going to have 1,600 equals 800 times e to the 0.095 times t, right? I'm looking for the t value there. Now, in order to solve this, what's the first thing you have to do? Divide by that 800, and so you get 2. So this is going to happen every single time, right? You double the investment. Isn't it going to equal 2? And if you were to triple the investment, what would it be equal to? 3. And quadrupling, 4, and so on. Okay, so if you, nice job, Brett. So you can think about that. Okay, in terms of what the equation is going to look like. Now, at this point, we can't get those bases to match, so we have to convert. Right? So it's time to convert. We're going from exponential to log form. So I'm going with a log base e, which is natural log. So I have the natural log of 2 equals 0.095 times t. And then all I have to do is divide by 0.095. Everybody agree? All right, plug it into the calculator. What do you get? Did you get 7.296?
Yep.
Now, this is in terms of time, so I want my answer in terms of years. When you give an answer, does it make sense to write 7.296 years? This piece, doesn't it just represent some days of the year, right? 0.295 well, not really percent, but of the year, right? That makes sense. Okay, that's an okay answer to give. So this is our answer here for that first piece. Okay. Now, for the next question, it says how much money are we going to have after 10 years have passed? So go back to your initial investment. Now I'm looking for my A value, right? I'm looking for the amount of money after this 10 years have passed. I'm still investing $800. It still has a rate of 0.095 or 9.5%. And 10 years is going by, so t is 10. And now I'm right back. So I went from a 3.4 application, right, where I'm actually solving the equation, to now I'm right back to 3.1, where all I'm doing is plugging this into the calculator. You should get $2,068.57. Again, in terms of rounding, you'd have to round to the 100th, and we need that dollar sign there. Okay? So it's going to be important on this next test on Wednesday that you make sure that you are, reading your units, thinking about what does it make sense to round to? Do I need to round to an integer value, or is a decimal okay? The third, the fourth, the fifth, second. You got to think about the place, okay, in your units. Last example.
Yes.
Okay. Let's talk about, we have looked at this before. Let's talk about the last thing, radioactive decay. You will be working with that one, but it's the same process. Okay? So we have Q equals C times 1/2 T divided by the half-life. Remember that C is that initial amount of material. T is your time in years. The half-life will literally say the half-life is this amount of years. And then Q is your amount after that time has passed, okay, left over. So for an isotope with a half-life of 1,510 years, starting with 10 grams, how much is left after 1,000 years? So, what do we have? Do we have C? That wasn't rhetorical. Do we have C?
Yeah.
Yeah, what is it?
10.
So 10. So I start with 10. So 10 times 1/2. Do I know how many years have passed? How much time has passed? Yep, they want to know after 1,000 years. So that's my 1,000. And then was I given the half-life?
Yes.
Yep. So it says the half-life is 1,510. Right, and I'm looking for how much material is left over. So I am looking for that value of Q. So here I am again, right back to 3.1. All I do is plug it into the calculator. There's no solving to do. When you put this in, make sure you put parentheses around the 1/2 and also that exponent. You should get 6.319, and then that answer would be in terms of grams, because you're talking about how much material is left over. Question?
Well,